Today we're going to get into how to solve a system of equations algebraically, meaning not using a graph, and this method is called elimination. So we're going to get started. So the elimination method can also be called the addition method because that's what happens in order for the variables to eliminate. And the idea is we want to cancel out our variables. So let's just go ahead and read this real quick. The elimination method of solving systems of equations is also called the addition method. To solve a system of equations by elimination, we transform the system such that one variable cancels out. So first step is to transform the system. Let's write that out again. The system in order to eliminate one variable. So this first step we're actually going to skip today. We're not going to focus on this step today. We'll do that tomorrow when we're doing more difficult problems after we get the hang of it today. So we're going to start off by just doing the elimination from the beginning. And first step is to eliminate one variable and solve for the other variable. Then substitute into either equation. And then finish it off by writing out the answer. Now, when we get our special cases, which is infinite solutions and no solutions, is if both variables cancel out. This will make a little bit more sense as we actually go through the examples. So let's go ahead and get started with the first one. So as we can see, we have our two equations. They're in standard form. So when it comes to elimination, we generally want it in standard form. It makes it a lot easier to solve this method. So we look at our equations. We're just going to go ahead and combine the two equations with each other, meaning we're going to add the two equations. That's why some people will call this the addition method. Others will call it the elimination method. So we're going to add the two equations vertically down. And the whole purpose here is we can see that 2x's, when we combine 2x minus 2x, they're going to cancel out. That's why it's called the elimination method, because they get eliminated. Then we're just going to solve the rest of it. I'm going to combine the y's. That's negative 5y. I'm going to combine the 10 and the 15 on the right, both negative. It's going to be negative 25. And to solve this, we just divide by negative 5. And y is equal to positive 5. There's our answer for that one. Now that we have the y value, we're going to go ahead and solve for the x value because we need the ordered pair. So I'm going to go ahead and pick one of my equations. This is step 3, which is substitute the value of the variable, y equals 5, into any equation and solve for the other variable. So we need to solve for x. So I'm going to recopy the first equation. So here's the first equation, and I'm going to take this equation and I'm going to replace this y value for a 5. So I'm going to go back and take off that y, and I'm going to replace it for a 5 because y is equal to 5. I know what its value is now. So I'm going to go ahead and plug in that 5 here. And from here on out, it's just a whole bunch of simplifying to get the x by itself. So using all those skills from solving equations that we have mastered at this point. So I'm going to add 15 to both sides. And then I'm going to go ahead and finish off by dividing. So 2x, these guys cancel. I have a 0 on the right side. In order for me to get rid of the 2 next to the x, I also divide again. And I get my x value, and x is equal to 0. 0 divided by 2 is 0. So now we have our x value, we have our y value. So I'm going to write out my final answer, which is these two lines, if I were to graph them, would intersect. And they would intersect at 0, 5. So let's write that out. Final answer is 0, 5. X goes first, y goes second. So if I would have used the second equation instead of the first one, I would have gotten the same exact answer. All right, here is number 2. Let's get started on this one. Same thing. We're going to see which ones eliminate when we go ahead and add the two equations. In this case, x eliminates again. So let's go ahead and cross those out. But wait a minute. If we combine the 2y and the negative 2y, those also eliminate. So we end up with absolutely nothing on the left. So we need to actually write something down. We can't just not write anything on the left side. So we put the number 0, since 4 minus 4 is 0, and 2 minus 2 is also 0. The right side, 6 minus 6 is 0. So this is that special case when we get no solution or infinite solutions, when both your variables cancel out. So you have to ask yourself, is 0 equals 0 true or false? In this case, this is a true statement. Therefore, my final answer here is infinitely many solutions. So again, true means everything works, and false means no solution. So we have infinite solutions here. All right, let's go ahead and move on to our next example. Same thing, we're going to go ahead and add our two equations. So I'm going to put the plus sign, and I'm going to add the x's. I'm going to add the y's. So negative 6x and negative 5y gives me negative 11x. Y minus y is going to eliminate. One's positive, one's negative. Bring down the equals. 19 and 3 add. They're both negative, so that's 22 negative. And to get x by itself, we divide both sides by negative 11. And x is equal to 2. So we have our x value solved for. Now we're going to do step 3 in our step 1 through 4 and plug the 2 into either the first equation or the second equation. I'm just going to pick the first equation. So we have negative 6x. Let's try a different color. So negative 6, and I'm going to replace the x, not the y, plus y equals negative 19. Substitute the 2 in here. And from this step on is just solving for y. So negative 6 and 2 is negative 12 plus y equal to negative 19. And then add 12 to both sides to get the x by itself. I'm sorry, the y by itself. And y is left alone now that the two numbers cancel, the 12s cancel. We're left with y equal to negative 7. So we have our x value and we have our y value. So my final answer here is that these two lines intersect at the point 2, negative 7. All right, let's get our last example done. So we're going to go ahead and add the two equations in order to eliminate. So that's our goal. So negative 8x and negative 8x do not eliminate, but negative 8y and positive 8y do eliminate. So we're going to end up with negative 16x. The 8y's and the negative 8y cancel. On the right side, we're going to combine the 24 and the 8. They subtract, and it's negative, so that's going to give us 16. Divide both sides by the number next to the variable, which is 16, and x is equal to positive 1. So we solve for x. Now we're going to plug that x back into the equation and solve for y. So this time, just to change it up, I'm going to plug it into the second equation, and I'm going to replace the x, not the y. So negative 8x minus 8y equals 8. So I'm using the second equation this time as opposed to the first one. It does not matter which one you use, you'll always get the same final answer as long as you do not mess up any of your signs or the work. So we have negative 8 minus 8y equal to 8. Then we're going to go ahead and move the 8 over by adding it over. So plus 8 plus 8. And we cancel, combine like terms and all that stuff. So negative 8y is equal to 16. And we always divide by the number next to the variable. And these cancel, and we're left with y equal to, 8 goes into 16 twice, and that's negative. So my answer here would be the point of intersection is at, let me write this down, make sure you always put the x first, 1, negative 2. And that's pretty much it. So just remember, eliminate, solve for the first variable, substitute back in, solve for the second variable by using any of the two equations. Remembering our special cases, like on number 2, where we got that 0 equal to 0. But if I would have gotten something like 0 equal to 7, that would have been false, which would have given you no solution. So go ahead and start your practice problems. You should be working on pages, I believe, 4 through 6. Good luck.